Section 225.30 addresses multiwire branch circuits. Paragraphs 3 provide exceptions to the rule requiring that multiwire branch circuit conductors be grouped within the same raceway, cable, or otherwise identified as a multiwire circuit. Now, according to Section 230.2 application, the last sentence states for the purpose of 230.40 exception number 2 only, service conductor supplying separate buildings or other structures on the same premises shall be considered as feeders. Let's consider an example installation. Suppose there are two 100 amp panels in each double-wide prefab structure, and the multiwire branch circuit conductors are not grouped within the same raceway, cable, or otherwise identified as a multiwire circuit. Based on this information, the installation is not compliant with 225.30. However, the installation could potentially be compliant if it is considered a service under 230.2 and 230.40. Exception number 2 to 230.40 permits service conductors to be installed in separate raceways or cables under specific conditions. For example, it is recommended to install the feeders to the prefabs as a service under 230.2 and 230.40. Using exception number 2 to allow the conductors to be run in separate conduits. This approach helps ensure compliance with all relevant code requirements. Additional considerations include labeling the feeder conduits clearly to identify them as service conductors. It is also important to ensure that the prefabs are permanently connected to the main school building using a ground fault path or other approved methods. The electrical system within the prefab structures must undergo proper inspection and maintenance to guarantee ongoing safety and code compliance. Therefore, the strategy is to treat the power supply to the prefabs as a service, not a feeder. This relies on using the exception in 230.40 that permits multiple service drops or laterals. This section specifically allows separate buildings on the same property to have individual services. In practical terms, each double-wide prefab unit would essentially have its own service entrance. This means installing a service disconnect to each unit. Because the code considers service conductors, you can run separate conduits to each 100 amp panel within the double-wide. However, you must adhere to the requirements for service entrances, including proper grounding and bonding. The exception in 230.40 is crucial because it addresses situations where a single building or structure is not practical to supply with a single service. This is often the case with temporary or modular buildings. The code recognizes that running multiple services might be necessary. The requirements for grounding and bonding are critical. Ensure that each service entrance has a proper grounding electrode system, typically consisting of ground rods, ground rings, or connections to a metallic water pipe. All metallic components, such as conduit and enclosures, must be properly bonded to the grounding system. This minimizes the risk of electrical shock and provides a path for fault current to safely return to the source. Labeling is another essential aspect. Clearly label all service disconnects and associated conduits. This helps identify the different services and prevents confusion during maintenance or emergencies. Use permanent labels that are resistant to environmental factors. Also, consider the physical protection of the service conductors. Ensure that the conduits are properly installed and protected from damage. The conductors themselves must be of the appropriate type and size for the applied load and environmental conditions. Overcurrent protection is paramount. Each service must have appropriately sized overcurrent protection, such as circuit breakers or fuses, to protect the conductors and equipment from overload or short circuits. Coordination of overcurrent protection is also important to minimize nuisance tripping and ensure selective clearing of faults. Coordination refers to the practice of selecting and setting overcurrent protective devices so that only the device closest to a fault opens, leaving the rest of the system operational. The location of the disconnects is another key factor. Service disconnects must be readily accessible and located either inside or outside the building or structure they serve, as close as practical to the point of entrance of the service conductors. This allows for quick and easy disconnection of power in case of an emergency. Inspection and maintenance are ongoing responsibilities. Regular inspections of the electrical system are essential to identify any potential problems, such as loose connections, damaged conductors, or malfunctioning equipment. Maintenance, such as tightening connections, replacing worn components, and testing overcurrent protective devices, should be performed regularly to keep the system in safe and reliable operating condition. The application of 230.40, exception number 2, is limited to specific circumstances. It is only applicable for service conductors supplying separate buildings or structures on the same premises. It cannot be used for feeders within a single building or structure. Also, it is crucial to consider the local amendments or interpretations of the National Electrical Code, or NEC. Local jurisdictions may have additional requirements or modifications to the NEC that must be followed. Always consult with the local electrical inspector or authority having jurisdiction, also known as the AHJ, to ensure full compliance. In summary, to make the installation compliant, you need to treat each double wide as a separate service. Install a service disconnect at each unit, ensure proper grounding and bonding, label everything clearly, and provide adequate overcurrent protection. This approach allows you to run separate conduits to each 100 amp panel, utilizing the exception in 230.40 for separate buildings on the same property. Always consult with the local electrical inspector, the AHJ, to ensure full compliance with all applicable codes and regulations. Using this approach, you ensure the safety and reliability of the electrical system while meeting all the necessary code requirements. Section 230.2 dictates the conditions under which a building or structure can be supplied by a service. This section outlines the general requirements for service conductors, including the size, type, and installation methods. Section 230.40 provides specific rules for the number of service entrance conductor sets allowed. The exception to this rule, exception number 2, is the critical component that allows for multiple services to separate buildings or structures on the same property. The phrase separate building or structure is important. The code defines a building as a structure that stands alone or that is cut off from another structure by firewalls with all openings therein protected by approved fire doors. A structure is defined as that which is built or constructed, an edifice or building of any kind, or any piece of work artificially built up or composed of parts joined together in some definite manner. In the context of the prefab classrooms, each double-wide unit, when connected, may still be considered a separate structure, especially if it retains some degree of physical separation or independence from the main school building. The same premises requirement means that all the buildings or structures being supplied by separate services must be located on the same property or campus. This is usually straightforward in the case of a school campus. Proper grounding and bonding practices are essential for safety and compliance. Grounding ensures that non-current carrying metal parts of the electrical system are connected to the earth, providing a low impedance path for fault current to return to the source. Bonding connects these metal parts together to create an electrically continuous path, minimizing voltage differences and reducing the risk of electric shock. Grounding electrode systems typically consist of ground rods, ground rings, or connections to a metallic water pipe. The specific requirements for the grounding electrode system are outlined in Article 250 of the NEC. Bonding is achieved by using bonding jumpers to connect metal components such as conduit, enclosures, and equipment grounding conductors. The size of the bonding jumpers must be appropriate for the size of the service conductors, as specified in the NEC. The labeling requirements are straightforward but critical. All service disconnects must be clearly labeled to indicate what they serve. This helps prevent confusion during maintenance or emergencies and ensures that the correct disconnect is opened when necessary. The label should be permanent and easily readable, even in adverse conditions. Overcurrent protection is provided by circuit breakers or fuses. These devices are designed to interrupt the flow of current when it exceeds a predetermined level, protecting the conductors and equipment from damage due to overloads or short circuits. The size of the overcurrent protection must be carefully selected to match the ampacity of the conductors and the rating of the equipment being protected. Overcurrent protective devices must also be properly coordinated to ensure selective clearing of faults. This means that only the device closest to the fault should open, leaving the rest of the system operational. The NEC provides guidance on how to coordinate overcurrent protective devices in Article 240. Accessibility of the service disconnects is another important consideration. Service disconnects must be readily accessible, meaning that they can be reached quickly and easily without the need to climb over obstacles or use special tools. The NEC requires that service disconnects be located either inside or outside the building or structure they serve, as close as practical to the point of entrance of the service conductors. This allows for quick and easy disconnection of power in case of an emergency. Regular inspections and maintenance are essential for maintaining the safety and reliability of the electrical system. Inspections should be performed by qualified electricians who are familiar with the NEC and local codes. During an inspection, the electrician will look for any potential problems, such as loose connections, damaged conductors, or malfunctioning equipment. Maintenance should include tasks such as tightening connections, replacing worn components, and testing overcurrent protective devices. The frequency of inspections and maintenance will depend on the age and condition of the electrical system, as well as the environmental conditions to which it is exposed. It is important to maintain detailed records of all inspections and maintenance activities. These records can be used to track the performance of the electrical system over time and to identify any recurring problems. The NEC is a complex and comprehensive document. It is important to have a thorough understanding of the code in order to ensure compliance and safety. There are many resources available to help electricians and other electrical professionals learn about the NEC, including training courses, seminars, and online resources. It is also important to stay up to date on the latest changes to the NEC, as the code is revised every 3 years. By following these guidelines, you can ensure that the electrical system in the Prefab classrooms is safe, reliable, and compliant with all applicable codes and regulations. This will help to protect the students, teachers, and staff who use the classrooms from the hazards of electricity. Finally, documentation is key. Keep detailed records of all electrical work performed, including permits, inspections, and any modifications made to the system. This documentation can be invaluable for future maintenance, troubleshooting, and compliance verification. Remember that electrical codes are in place for safety. Adhering to these regulations protects people and property from the dangers of electrical hazards. When in doubt, always consult a qualified electrician or your local electrical inspector for guidance. By approaching this project with careful planning, attention to detail, and a commitment to safety, you can ensure a successful and compliant electrical installation for the Prefab classrooms. This installation would involve treating each double-wide as a separate service, which allows for compliance with the NEC while providing safe and reliable power to the classrooms. Remember to always consult with your local authority having jurisdiction (OJ) for any specific requirements or interpretations in your area.